Have you ever been coding and thought, there has to be a better way to handle this giant list of things? Well, there is. Today, we're going to crack that problem wide open with one of the most fundamental tools in programming, the array. Let's jump right in and see how you can organize your data like a total pro. So, here's the game plan. First, we'll look at a really common coding headache. Then, we'll introduce arrays as the perfect solution. After that, we'll get hands-on, first with 1D arrays, and then we'll level up to 2D arrays. And of course, we'll wrap it all up with a super quick recap of everything you need to know. All right, let's kick things off with a challenge that, trust me, every single programmer bumps into when they're starting out. What do you do when you have a ton of similar data? Just think about it for a second. You need to keep track of 100 test scores. I mean, you could make 100 different variables, right? Score 1, score 2, score 3, all the way to score 100. But wow, that sounds tedious, and honestly, it's a recipe for a messy program. And this right here shows you exactly what I mean. On the left, you've got the inefficient way, a separate variable for every single piece of fruit. It's clunky, it's long, and it's just hard to work with. But then, look at the right. A hint of something so much cleaner. All the fruits tucked away neatly inside a single variable. That, my friends, is an array. So, how do we get from that chaotic pile of variables to that beautiful, organized box? Well, it's time to meet the hero of today's story, the array. So what exactly is an array? You can just think of it like a bookshelf, right? Instead of having books scattered all over your floor, you have one single bookshelf where they're all lined up, neat and tidy. An array is that bookshelf for your data. So why should you care? Well, first off, they keep all your related data in one spot, super organized. Second, they make your code way shorter and so much easier to read. And third, and this is the real game changer, they let you use loops to work with your data. That means you can do the same thing to every single item on your list with just a couple of lines of code. It's incredibly powerful. Okay, enough theory. Let's get practical. How do we actually build one of these things and use it? We're going to start with the most basic type, the one-dimensional array. Honestly, it's just a simple list. In a language like Python, this is literally all it takes. We make one variable, we're calling it fruits, and we assign it a list of items inside square brackets. Just like that, apple, banana, and cherry are all living happily together in one place. Now hang on. Before we go any further, there is one absolutely crucial rule you have to burn into your memory. In programming, we almost always start counting from 0, not 1. This is called zero indexing, and you have to understand it to work with arrays. This little table breaks it down perfectly. The very first item, apple, isn't at position 1. It's at what we call index 0. Banana is at index 1, and cherry is at index 2. This index is basically the address of each item in our array. So let's say you want to grab the second item in the list. You have to ask for index 1. This code, printFruits1, is telling the computer, hey, go into the fruits array and give me whatever you find at index 1. And of course, that's banana. And what if you want to change something? It's just as easy. Fruits at 1 equals pear says go to index 1, and whatever's there, replace it with pear. So goodbye banana, hello pear. It's a really simple and direct way to manage your data. And this is where the magic happens. This is where it all comes together. When you combine an array with a loop, you can process massive amounts of data with almost no code. This simple loop just automatically goes through each index, 0, 1, 2, and prints out the value it finds. Now imagine doing this for those 100 test scores. A tiny loop saves you from writing 100 different print statements. All right, you've mastered 1D arrays. Let's crank it up a notch. What if your data isn't just a simple list? What if it's more like a table with rows and columns? Well, for that, we have 2-dimensional, or 2D arrays. Take a look at this marks array. It's a perfect example. It has 2 rows and 3 columns. You can think of it like an array where each item is another array. So row 0 holds the scores for one student, and row 1 holds the scores for the next student. It's basically a spreadsheet built right into your code. To grab a specific value now, we need 2 coordinates. It's kind of like playing Battleship. You need the row number and the column number. So marks of 0, 2 tells the program, okay, go to row 0, then go over to column 2. And remember, since we start at 0, that lands us right on the number 80. So how do we visit every single cell in this grid?
We use a really cool trick called a nested loop. That just means you put a loop inside of another loop. The outer loop takes care of the rows, going from one row to the next. And for each of those rows, the inner loop zips through all the columns. It's a pattern that lets you systematically check every single piece of data in your table.
Whew, okay, we have covered a ton of ground. So let's just take a breath and boil it all down to the key things you absolutely need to remember. All right, let's lock this in. First, arrays let you store a bunch of related values under one single name. Simple. Second, they're zero indexed. You always start counting from zero. Third, their real power comes alive when you use them with loops. And finally, for 2D arrays, you pinpoint data using a row-column system. Got it? Good. Look, arrays are so much more than just a way to store some numbers. They are the fundamental building blocks for almost everything, from keeping track of items in a video game to analyzing huge sets of scientific data. You now have a seriously powerful tool in your programming toolkit. So, the real question is, what are you going to build with it? Thanks for tuning in.